Okay, so good afternoon, everybody. So I finished chapter 3, but there is only one very small topic I want to finish here. I finish everything else. This topic is about relays. I think it's important to learn it because probably you are gonna need it in your capstone relay. So let me explain what is the relay. How we are going to use it, why they are important, and all these things. So let me start with the problem we have. So we have microcontroller here, guys, okay? And then you have a motor here. For example, this motor, for example, needs 110 voltage to work, okay? So now the problem is how I can control this motor using the microcontroller. In other words, how microcontroller can turn the motor on or off. You got what I'm saying? For sure, it's impossible. It's impossible to connect it directly this way. It's impossible to do that simply because the voltage we can get here, we can only get 5 volts. Is that okay? So this is one problem. The other problem is this is DC, it's not AC. However, this motor needs AC, not DC. And this motor needs 110 voltage. Not only that, also this motor needs too much current, ampere, okay? So microcontroller cannot give this amount of ampere or this 110 voltage to the motor. You got what I'm saying? So now the question I'm gonna return to, so again, we cannot connect it directly as we did before, for example, for LED. Yes, if you have an LED, yes, you can connect it directly because all what you have to do, I mean, you can just put 5 volt or 0 volt, which is enough, okay? It's enough to turn the LED on and off, okay? However, for motor 110 voltage, no, you can't do this. So what can we do? Okay, in order to solve this problem, we're gonna use relays. Okay, how? So number one, how they work? How can I connect them to the microcontroller? Okay, how we can program them? I'm gonna answer all these questions. So the idea here, instead of connecting directly this way, you have to put here what we call a relay. So tell me what is a relay? Okay, and how it works. I'm gonna, but again, at least you know now. At least you know now why or how we can need relays or how relays can be used, okay? So the idea is that if you look how the relay is connected or the structure of the relays, there is a coil here, okay? Coil, okay. And now, and here we connect the microcontroller here. So here, this is a ground. And then we connect it to the microcontroller this way. Is that okay? And then you have a switch here. This is switch, for example, it can be like a mechanical switch this way, as you see here, guys. And then I can connect the motor this way. And then I can put here 110 volts. Here 110 volts. Here there is air. So there is no electrical connection here. Okay. So how it works? What is the main idea? Very simple. The way it works is that you connect it to one pin, just one pin. All what you have to do is just to put 5 volt here or put one logic 1 on this pin. Once you do that, actually you energize the coil. So the current has to go this way. You energize the coil, and when you energize the coil, the coil turns into a magnet. So it becomes like a magnet, okay? When it is a magnet, it's gonna pull this switch down here to close this circuit. You got it? Okay. So this is the main idea. And this coil only needs just 5 volt. It doesn't need too much current. Okay. It doesn't need high voltage. Okay. And now so again, very simple. Once you put here 5 volt, you actually energize the coil. The coil is gonna make a magnet. It's gonna pull the switch this way to close it this way. Okay. Once you put 0 volt here, once you put 0 volt here, actually there is a spring. We use a spring here. The spring is gonna pull the switch up. Okay, that's why you disconnect the circuit. Very simple. So now all what you have to do is, if you wanna run the motor, all what you have to do is just put here 5 volt. If you wanna stop the motor, all what you have to do just put here 0 volt. Okay, guys. Any question? So this, it comes, as you see here in the picture, it comes in one package, as you see it here, as you see here in this picture. I'm gonna show a video now, but if I wanna teach more before I show the video, okay? So we have two types of switches. One switch, we call it normally open, NO. What we have right here is normally open. So what do you mean by normally open? It means if I put here 0 volt and if I don't energize the coil, it's gonna be open, normally open. And once I energize the coil, it's gonna be closed. Okay? This is what I mean by normally open. We have other kind of switches, we call it normally connect. Normally connect. Okay? How this is different? I'm gonna tell you how this is different. So the idea is that normally the switch here, the microcontroller, normally the switch, for example, I can put like a switch here this way, and from here to here, this is normally connected. So normally it is connected. That means if the coil is not energized, it is connected. Okay. And now once you energize the coil, this one is gonna come here, and now it is open. Is that okay? So again, very simple. So we have two types of switches. One of them is called normally open, and the other one is normally connect. Normally open means it's normally open. Once you energize the coil, this one close, and this one normally closed. That means it's normally closed. And once you energize the coil, you are gonna make it open. Okay, so we have two types of. So the question is, which switch I have to use? Very simple. It depends on your application. In some applications, I want to use normally open. In some application, I want to use normally closed. Okay, so give me example. I'm going to give you example. For example, if I have an application, in this application, the circuit should be off unless I need to turn it on at a certain time. I want to turn it on. Okay, like for example, a motor here. So the motor is not going to run all the time, right? So no, it's going to run only when I energize the coil. There is other application, I need something to be normally connected. It's connected all the time. Is that okay? Unless I decide to turn it off. You got what I'm saying? So anyway, so it depends on the application itself. Usually it's the same relay, the same package comes with the two switches. Okay, and then you can select whatever you like. I want to tell you here, guys, on our board we have a relay here. You can see the relay here. Okay, so now I explained what is the relay. I explained how we can use it. I explained the idea of normally open, normally closed. There is only one thing missing. Okay, here is actually. Okay. Here, this is a microcontroller, guys. As I told you, I'm not going to connect it directly to 110 voltage. I'm going to connect here to a coil this way, okay? And here, this is a switch this way, okay, as I told you. However, we're going to have another problem here. What is the problem? I'm going to tell you what's the problem. Usually, if you have like a relay like this one, or even if you have a small motor, DC small motor, usually it needs too much current, okay? So the microcontroller cannot give enough current to the coil to energize it. You got what I'm saying? This is completely different from the problem I explained right now. Here the problem is 110 voltage. It's a completely different problem, okay? So the problem here, the voltage is okay. However, the problem, microcontroller, I'm going to use some random numbers. For sure, if you need to get the exact numbers, you have to look at the data sheet. For example, Microcontroller, for example, maximum is going to give me like 150 milliampere. However, the microcontroller needs at least 100 milliampere. Is that okay? So how we can solve this problem? Okay, this is also something very important you should learn, because you may need, for sure, I think you are going to need it in your capstone because it's very widely used. So the way we do it is we connect here. Okay, we connect here a circuit. This circuit, it has several names, but one of the names we use buffer. Okay, so the idea is that here, so you have here electronic circuit. Usually the same voltage here should be the same voltage here. However, this circuit is going to take little current from here. It's going to drive much current here. Okay, so give me a very simple idea to this circuit is transistor. Okay, so the idea is here, instead of connecting, by the way, what I'm saying, guys, is you may not have a problem. If the current you can get here is enough to energize the coil, you don't have a problem. It should be okay, right? I'm saying, but usually this may not be the case. So the way you are going to do it, guys, I'm going to use a transistor this way, for example, and then I'm going to put the coil this way, as you see here. Okay, so the coil, okay, I'm going to make it like, okay, so I'm going to put the coil here. Okay, so what's going to happen is when I put here 5 volt, you know, I'm going to turn the transistor on, and then the current here is the base current. As you know, the base current is very little current, and the current here coming from here, this is the collector current, and the collector current is much bigger than the base current. Is that okay, guys? Again, this is, I'm sure in your capstone, again, how can we use this, guys? Again, the problem is that the problem happens when you have microcontroller. Microcontroller can give you, for example, maximum 50 milliampere. However, you want to connect a circuit here, whatever the circuit is. This circuit needs, for example, 100, 200 milliampere DC. Okay, everything is DC. So how can we do it? There are like, you will find a lot of usually used transistors. Sometimes you can find IC, one chip IC. This IC has multiple transistors inside this way. Okay, any questions? We still have another problem. Okay, what's the other problem you have? I'm going to tell you what the other problem you have. From what you learned before, when you energize a coil, this way, this coil is going to store energy. It's going to store energy, and once you turn it off, so this one is gonna discharge this way. You got what I'm saying? It's gonna discharge the energy it is storing. Is that okay? So what happened here? If you don't have a protection here, this one is gonna discharge here in the transistor, and it may damage the transistor. That is why usually we don't do it this way. So now, usually the way we do it, we put it this way, guys, and then we put a diode this way. We put a diode this way. Okay, you know why? Because the current will be there here. When I turn it on, the current is going to go this way. However, when I turn the transistor off, now the stored energy is going to go this way. Okay, instead of damaging the transistor. That's why usually we put a diode this way. Any question, guys? Again, I'm sure, and again, almost everything I taught today is not microcontroller, it's electronics, but it's very important because I'm quite sure you are going to need it in your capstone. Okay, so usually we put here a diode for protection, so that here it's going to be have a base here to discharge when you turn the transistor off. Okay, guys, any questions? Okay, so we have a video here. I don't have much time to run the whole video, but so this video, just all what you have to do, guys, just go to YouTube, just type here how relays work. Okay, so as you see here. Hey there, guys. In here, an engine monitor comes to the larger switching relay. And they guarantee that so maybe controlled by one signal. Relay ensures complete electrical isolation between the controller and the control circuit.
relays are often used in circuits to reduce the current that flows through the primary control switch. A relatively low amperage switch, timer, or
for sure, instead of using a switch and using DC battery like this one, okay, here I put the microcontroller as I have just explained. Okay, so yeah, we have two parts. One part is low current, one part is high current, AC. Okay, as you see here.
Sensor can be used of this a little later in the video. There are two main circuits in the relay, the primary side and the secondary side. The primary circuit provides the control signal to operate the relay. This would be controlled by a manual switch, a thermostat, or some other type of sensor. The primary circuit is generally connected to a low voltage DC supply. The secondary circuit is the circuit which contains the load which needs to be switched and controlled. When we talk about a load, we mean any device that will consume electricity, such as a fan, a pump, a compressor, or even a light bulb. On the primary side, we find an electromagnetic coil. This is a coil of wire which generates a magnetic field when current passes through it. When electricity passes through a wire, it creates an electromagnetic field. We can see that by placing compasses around the wire. When we pass a current through the wire, the compasses change direction to align with the electromagnetic field. When we wrap the wire into a coil, the magnetic field of each wire combines together to form a larger, stronger magnetic field. We can control this magnetic field by simply controlling the current. By the way, we have covered how solenoid coils work and even how to make your own solenoid in our previous videos. Do check that out. Links can be found in the video of the component which is pivoted. When the electromagnet energizes, it attracts the armature. When the electromagnet...
So it becomes like a magnet. It's going to pull the switch as you see here. Once you de-energize it back, once you de-energize the coil, so that this spring is going to open the circuit as he's going to
de-energize, the armature returns to its original position. Typically, a small spring is used to achieve this. Connected to the armature is a movable contactor. When the armature is attracted to the electromagnet, it closes and completes the circuit on the secondary side.
Hey, Tennessee homeowners. Heating bills are expected to increase by up to 54%.
Anyway, I don't think anyway, you have the video here, you can see it. Yeah, that's what he's explaining here what I explained about the idea of normally open. So here, this circuit is normally open, okay? And then once you energize, you close it. This one is the other way.
However, when a current is passed through the primary circuit, a magnetic field is induced in the electromagnet. This magnetic field attracts the armature and pulls the movable contactor until it touches the terminals of the secondary circuit. This completes the circuit and provides electricity to the load. With the normally closed type, the secondary circuit is normally...
So it's normally closed as you see here, okay? Although he's explaining the concept on two different relays, in reality, when you buy one relay, inside the same relay, you can find multiple switches are normally open, other switches are normally closed on the same relay. You got what I'm saying?
And so the load is on. When the current is passed through the primary circuit, the electromagnetic field causes the armature to push away, which disconnects the contactor and breaks the circuit. This cuts the supply of electricity to the load.
I think that's enough for this one.
Inside. This provides power to the cooling fan as well as the warning light.
Okay. Anyway, I think that's enough here. That's what we need. So now I want to return to what I'm explaining here. So if you look on the board here, on the board, we have a relay. Let me go back to the picture of the board. Yeah. If you look here, guys. Yeah. We have a relay here. And we have three switches, as you see here. If you read whatever written here on these switches, you will find. So one terminal here is common. This is a common terminal, and one of them is normally open, and the other one is normally closed. You get what I'm saying? So if you see what is written here, Yeah, it's here. It's written normal. You can see it's written normally open, normally closed on in two sides. Okay. So anyway, so one more thing we have, there are different types of relays. The relays I'm explaining here, we call them like mechanical relays, mechanical because it has mechanical parts. There are other relays are solid state. Okay, they are electronic. Okay, so that is why when you energize this relay, you hear some sound, tick 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 tick. This sound is coming from contacts. Okay, so anyway, so now let's return to electronics. That's okay. So how can we program? How can we program it? Okay, that's very simple. So all what you have to do. So here. So guys, this is a microcontroller. Okay, you have only one pin. This pin is connected to whatever. Okay, we don't care about how everything is connected now. Okay, so now if you have just one pin. Okay, so programming wise, nothing is new. All what you have to do, number one, you have to program this pin output as we did before. Number two, if you want to energize the coil, you have to put logic 1 here of 5 volt. Otherwise, if you want to de-energize it, just put 0 volts. That's it. So from the microcontroller point of view, nothing is new. This is similar to what we have been doing. Just one pin on the microcontroller, you put 5 volt or you put 0 volt. Is that okay? So yeah, so here in this program, I'm explaining, here. Yeah, so here I'm explaining what is the relay, how we use them and so on. But the relay here is connected to the pin PE2, as you see here, guys, PE2. So the way you have to use it is, as we always do, number one, you have to program this pin output as usually we do. Number two, all what you have to do, just bit set, as you see here, guys, bit set and bit clear. That's it. So here, bit set to put 1 to energize it, otherwise bit clear to put 0 to de-energize it. Is that okay? Any questions? Yeah, sure. It's the same thing in C language. So in C language, you can do the same instruction like this one in C language. You got what I'm saying? You can say DDRE is equal to like 0xFF, right? Or if you want to change some bits, you can use AND or you can use OR. It's exactly the same thing. Initialize? No. Here there is no this is the only initialization you have here, just for the direction. That's it, right? So it's going to be exactly the same thing, okay, as we did before for port for port B and port H, other ports, exactly the same thing. Okay. I want to tell you here, guys, for safety, you should not use 110 with voltage, okay, in this course. Okay, so I'm teaching the concept of relays. However, I don't want you to use 100 volt for in your project for safety issue. Any questions? Okay. Now, guys, again, the reason for microcontroller, nothing is new. I didn't teach anything new. Okay. However, I think this topic is important because most probably you are gonna need this topic in your capstone. Okay. In any real application, you need relays, so you should know what relays mean. Also, you need the concept of power. Of buffer, as I explained, buffer. So this way here, you should understand why you are using this transistor this way. Okay, why you put the diode here this way. Okay, I think I'm done with chapter 3. Okay, any question in this chapter? Yeah, sure.
On that picture, where do you put the diode? Where's the diode built into the board?
Yeah, so you mean here inside the package itself of the relay? I don't. You can check what kind of relay you have, but I don't think they come with the diode, simply because Simply because you may not need it. It depends on the circuit. It depends on how you connect it. You got what I'm saying? So you need to connect it externally. Also, you usually if you search about buffer, usually it's not only one transistor. Sometimes you can have like a chip with multiple transistors inside it. Okay. But again, there is also a limit. There is a limit on the amount of current you can have here. There is a limit. Okay. So anyway, now I'm gonna move to chapter 4. In chapter 4, guys, I taught almost everything except this program. So I'm gonna start with this program. I'm gonna teach it. Then, as I told you before, I have added one section. The department asked me to add this section this year. It's very simple. So it's gonna be about serial communication interface. You will see how I use interrupts like IRQ and RTI to do serial communication. But let me finish this program first before I do this one. So let's see this program. I think I taught everything else, right? I think I taught everything in this chapter, only I didn't teach this one. Okay, so let's explain the idea here. So the idea here, like when I use the microcontroller to program traffic light, So the idea is, I'm assuming we have two streets. Okay, like for example here, Spring Street and Willow Street. So you have intersection here. So you have two streets this way. There is intersection here. As you know, if this street, if you allow cars to drive this way, so these cars they should stop here. So that's why you use traffic lights here. So the idea here, this is how it should work, guys. If one street is green, the other one should be red, right? So, and I want this state to continue, for example, for 5 seconds. So I wanna make this street green, the light of this street green, and the light here has to be red for 5 seconds, for example, okay? And now after, that's what we call here, that's why here I make it like states. We have different states. We move from one state to another. So I'm gonna move from one state, and then after 5, I'm gonna come back to 0 again. We move from one state to another. Also, I'm gonna stay in every state different time. So here, state 0 should continue for 5 seconds. State 1 should continue for 1 second, and so on. So I want to program it this way, so that as you see here, guys, one street is green, okay, the other one is red for 5 seconds. After 5 seconds, the second one here, this one should turn it to yellow. The other one is red, and this should be for 1 second. And then both of them are red for 1 second. Makes sense, right? And then now this is green, and this one is red for 5 seconds. And now this one is yellow. After 5 seconds, this should move from this state to this state. Now this one is yellow, and this one is red. Now both of them are red for 1 second, and then you go back to this state again. Again, you understand how it works? So again, simply, we have 6 states, as you see here, 6 states. And in every state, we spent some time, as you see here. Once I come to this state, we are going to go back to this state again, okay? So the way we are going to program it, guys, we are going to use the LEDs. We're going to use the LEDs on port B, the LEDs, okay? So here, here we are going to assume the first three LEDs for one string, the other 3 for one string. I'm going to assume here this LED green, yellow, red, okay? And so this is the LEDs. So that's why you should see here in the very beginning, for example, if this one is green, this one has to be red, okay? Look at the logic, okay? So if this one is green, this one should be red for 5 seconds. And then now, after green, this one should be yellow. And now this one should be red. And now this one should be green, okay? And for 5 seconds, yellow, red, and so on. Before I choose a program, I want to choose a video first to understand better how it works. So remember, guys, 1, 2, 3. We are going to use three LEDs for one street, and then 1, 2, 3 for another street. Remember, this one is green, yellow, red, green, yellow, red. So now what we see now here, this street is green, right? This street is red, okay, which is state 0. Okay, let's see. So it should continue for 5 seconds. Look, it's going to happen after 5 seconds. This one should move from green to yellow for 1 second, and then now both of them are red. Okay, then after both of them are red, now this one is green for 5 seconds. After green should be yellow, and then both of them should be red again, and then this one will be green, and then repeat. You look here. Now this one is, now both of them are red. Now this is green. Is that okay, guys? And so on. Any questions? Okay. So again, what's important in this program, you should understand the idea of states. We have states, number one. Number two, you should understand the idea that we move from one state to another. You should understand the idea that we're gonna spend different times at each state. For example, this one I'm gonna make it 5, this one I'm gonna make it 1, and so on. So how can we program it? It looks like it's difficult. No, it's very trivial. I'm gonna tell you how. Look how we are gonna do it. Look here, guys. The way I'm gonna do it is I'm gonna define here, as you see, I'm gonna define two arrays. One array is called LEDs, the other array for the delay. Okay. So the way I'm gonna do it, as you see here, guys, if you are in state 0, state 1, state 2, state 3, and so on until state 5. Is that okay? So all what I'm gonna do is, if I'm in state 0, this is the value I have to put it on port B, as you see here. Okay, in order to turn, I'm gonna turn like here. I'm assuming this one is red for some reason. So green, yeah. This one is red. So here, this is red, and this is green. Okay, as I told you. So this is one street. This is the other street. Anyway, so here, whatever is the value. So in state 0, whatever is the value you wanna put it in port B, just put it here. Okay. So what's gonna happen is, okay, guys. So if I'm in state 0, so I have to take this value. I have to write it on port B. If I'm in state 1, so I have to take this one. State 2, state 3, state 5, and so on. Is that okay, guys? So it's very simple idea. So what I'm gonna do, guys, is I'm gonna use a counter. This counter, I'm gonna call it IX. Okay. So in the very beginning, IX is 0. Okay. So I'm gonna take this one. I'm gonna send to port B. Okay. Then I'm gonna increment it to become here. Take this one to port B, increment it. Once I come to here, I have to go back to 0 again. You understand what I'm saying? So very simple. So here you have like a counter. This counter should start from 0, 1, 2, 3, 4, 5, and then go back again. Okay. I don't remember start from 0, start from 1. Let me see how. Yeah. I think we start. Yeah, we start from 0, as you see here. Anyway, and after we come to 5, you have to go back to 0 again. Okay, guys. So now it's easy. This is the value I have to put it in port B. Okay, and then I am gonna take 1. I'm gonna send to port B. Then after some time, this is an important point. This is a trick. Okay. So again, the easy part is I'm gonna use a variable. This variable is gonna tell me 0. Take this one, send to port B. That's the easy part. Now the difficult part is, in order to move from one state to another, I'm gonna have different times. That means here, IX in the very beginning, IX is here. I'm gonna take this one and then I'm gonna send to port B. Is that okay? Then, this is the difficult part. Then, after 5 seconds, I have to come to here after 5, and then take this one, send to port B. Then after 1 second, not 5, after 1 second, I have to take this one to send to port B. Is that okay? Then here, after 1 second, I'm gonna come here take this one, send to port B, and I have to stay in this one 5 seconds. So the question is how I can control the time here, okay? How I can control the time? I'm gonna tell you how it's also very easy. The way you are gonna do it, guys, using the number of interrupts. Okay, what do you mean? I'm gonna tell you what I mean. Look here, guys, the idea very simple, very interesting. So the idea is that if we create interrupt every 10 milliseconds, so we have interrupt every 10 milliseconds. That means if I want to stay in this state for 5 seconds, so that means I have to move to the next state after 488 interrupts, because 488 interrupts means it's around 5 seconds. Is that okay? Same thing here. If I'm in this state, in order to move from this state to this state, okay, so I need to spend, I have to count 98 interrupts and so on. Okay, I'm gonna clarify it more, but again, you can see here, guys. Well, I'm gonna create another array. This array should have how many interrupts I have to count before I move from one state to another. You got what I'm saying? So again, if I'm in state 0, so number 1 IX should point here. So I have to take this one, I have to send to port B. That's okay. Also, I'm gonna take here, because IX is 0, so I'm gonna take this value here, I'm gonna put this one in another variable. This one, I'm gonna call it D time. Okay. This D time, I'm gonna count this number of interrupts before I move to the next state. You got what I'm saying? So as you will see right now, guys, let me show you the program. It's a very simple program, but you should learn the idea of how can we control the time this way, okay? So as you see here, guys, all what I did here in the main program. So everything is gonna be done by RTI, as you will see right now. So just here in the beginning, I just do a initialization. Yeah, just I do here initialization. And then again, I told you I have 2 variables. One is called IX. IX should be, again, it's a point to tell me which state. So IX should have a value 0, 1, 2, 3, 4. And then after 4, you have to come back to 0 again, right? Because we have here, after 4 or 5, I think 5, because we have here. So this is state 0, state 1, 2, 3, 4, 5. So after 5, I have to come here. Same thing here. If I'm state 0, so 1, 2, 3, 4, 5. So we have here IX should point on what is the current state, okay? And every time we have to increment IX. Anyway, as you will see right now, this is one thing. The other thing is we need another counter for how many interrupts I have to receive before I move to the next state. This is what we call D time. D time. So let's explain how it works, guys. So look here how it works. The idea is that every time there is an interrupt, I'm gonna decrement D time. Is that okay? Every time I'm gonna decrement D time. Okay. However, I'm gonna put here if statement. This part is gonna be executed only when D time is equal to 0. Okay. This part should move from one state to another. That means if I want to stay 5 seconds, you know what I'm gonna do? All what I'm gonna do, I'm gonna put here 488, right? 488. So I'm gonna put here 488. That's it. And then what's gonna happen is every interrupt I'm gonna decrement by 1. Is that 0? No, just leave. Okay, decrement by 1, decrement by. So after 488 interrupts, I'm gonna come here, and here I'm gonna change it to the next state. You got the idea? And when I change to the next state, now I'm gonna reinitialize D time again by the value I have here, 98. So that means next interrupt after 98. If I put 98, that means, sorry, not next interrupt, next change, because the interrupt here is fixed. We make interrupt every 10 milliseconds, 10.24 milliseconds. Okay. However, this part is going to be executed every D time when D time is equal to 0. Okay. That means I can say if I put here 488, that means next change is going to be after 488 interrupts. If I put here 90A, that means I'm going to come here after 98 interrupts, or next change is going to change it to the next interrupt, next state. It's going to be after 98 and so on. So let's see how it works here, guys. As I told you, once it is 0, you know what I'm going to do when it is 0? That means I have to move to the next interrupt. Okay, as you see here, the way I'm going to do it, I'm gonna read the value. Very simple. I told you we have here IX. I'm gonna take the value pointed by IX here. I'm gonna send it to port B. Same thing here. I'm gonna take the value pointed by IX. I'm gonna put it in D time, so that next change is gonna be after this value. Okay. Also, I'm gonna increment IX. So every time I take a value bounded by IX, I am gonna increment IX. And now, if IX is equal to 5, this value, this is just a variable. I initialize this variable with 6. Okay, so after you finish 5, after you finish step number 5, you increment IX. So now, when IX is 6, so I have to return it back to 0 again. You got what I'm saying? Once I come to 6, when I finish 5, increment IX. IX now is 6. Once I come to 6, so I'm gonna return it to 0 back again. You got what I'm saying? So as you see here, guys, that's exactly what I explained. Every time D time is 0, so I'm gonna take a value from LEDs. You remember this function? This function actually what happened here? Port B is equal to LEDs IX. So I'm gonna take a value. I'm gonna take the value of is an element number IX. I'm gonna send it to port B. Same thing. I'm gonna do the same thing here, guys. But this time I'm gonna put it at D time, so that next change in the state is gonna be after this value here. Okay. Then I'm gonna increment IX. If IX is equal to 6, so now make it 0, so that after state number 5, you go to state 0 again. So now, guys, I like this program. It's an interesting program, and you can find many applications for this program other than the traffic. So in any program or in any application that has states, okay, and every state can spend. I need to spend some time in different times in the states. So you can use this idea or this program. Okay, guys. Any questions? Any questions? Is it clear how it works? Very important. I'm going to repeat it because I think this is a common mistake between students, guys, among the students. So here, IX and D time, it has to be global variable, because I'm gonna use them here inside the interrupts. You got what I'm saying? And I want to keep the last value, so they have to be global. If you define them inside the main program, you are going to receive error, because also same thing, if you define them here, so once you end, as I explained before, once a subroutine ends, these values are gone. So they are not going to remember the last values. Is that okay, guys? Any questions? Okay. Okay. Now I'm going to move to the last part here about serial communication interface, guys. Let me go back to the table I have here. I told you again, what we did so far, guys, I explained in this chapter, I explained the idea of interrupts, okay? We had one lab about interrupts. I mainly explained two types of interrupts, IRQ and RTI. I explained these two interrupts. We had one lab. Also, we had one test about these two interrupts. And I told you we have more sources of interrupts. We have a table here. Maybe I want to choose a table here. Yeah. So as I told you guys, what I'm gonna do in chapter 5. In chapter 5, I'm gonna teach the timer system. As you see here, the timer system has many interrupts, around 8, 10. No, not sorry. I'm sorry. I need this. So we have 9 interrupts in the timer system. I'm gonna explain them here. 9 interrupts here. Is that okay? Today I'm gonna explain the serial communication. Interrupts. First, what do you mean by serial communication? What serial communication means? Okay, I'm gonna tell you what I mean by serial communication. Actually, we already did, if you remember, we did one lab about serial communication, and we have here one program. Sorry, it was not here. It was in chapter 3. Just to understand the idea of serial communication, just I want to remind you of this program. Yeah, okay. You remember, yeah, I think it was the first program or second program I taught here. Yeah, this one. Okay. So yeah, this was like a serial communication. So serial communication means, as I told you before, guys, you have one pin. You can send the data serial. Okay. What you mean by serial? 101010. You have a certain time, as we did before. For example, here you have here for a certain time. For here, as you see it, for a certain time, we have 0. One pin, and then you have 1, and then you have 0, 0. Okay, and then you have 1, 1, 1. Okay, and then here what we did, we repeated the same byte, repeated multiple times so that we can see it. Okay, so it's just one pin. In this pin, every certain time, certain period of time, you can only get one bit, right? Either 0, 1, 0, 1, 0, 1. Is that okay? That's what we mean by serial communication. Is that okay? So also there is something we call it the baud rate. The baud rate is the speed of transmission. For example, if the baud rate is 900, that means we are going to transmit 900 bits in every second, the speed. Okay, so the higher the baud rate, the higher the speed. Okay, how many bits you are going to transmit in 1 second? Is that okay? So so here on this board we have 2 serial communication, guys. Let me go back here. So again, we have 2. Let me come here. Yeah, we have 2 serial communication, guys. One is called SCCI 0, and we have SCCI 1. So I have 0 and 1. And 0, we already have used 0. Okay, SCCI 0 is used in order to enable communication between your laptop and between the board. So if you see what is written here, when you connect the USB, this one is using SCCI 0. Okay, so here we already use SCCI 0 for the communication between the board and the laptop. Is that okay, guys? So what I'm going to teach today, I'm going to teach SCCI 1 here. Is that okay? Let me ask you a question. So now you understand what I mean by serial communication. Okay. Also, we have here, it's in the table of interrupts. That means this receiver, this serial communication can trigger interrupts like RTI, like IRQ. That's okay. But when I taught in the very beginning, when I taught interrupts, I told you interrupts means event. There should be an event. Is that right? Like, for example, in IRQ, the event is there is a falling edge. Okay. And because of this event, we're going to execute a subroutine. This is a very basic, very important definition for interrupts. Interrupts means there is an event, and as a response to this event, we're going to execute a subroutine. Is that okay? That's what I said. So same thing for RTI. In RTI, the event was a time out. For example, every 10 milliseconds, this event is time out. It's you already spent 10 milliseconds. Okay. Anyway, now in the serial communication, so what is the event here? I'm going to tell you what is the event. The event is if you are expecting, if you want to receive data, if I want to receive data. So there are 2 ways. One way is to do polling to check. Have I received the data? No, you didn't. Have you received the data? No, I didn't. Have you received polling? Okay, which is for sure, polling is not a good idea. The other idea is once you receive a data, you trigger interrupt. That means when there is an interrupt coming from the serial communications, that means the microcontroller is telling you, I have received the data, please come and take it. That's it. Okay, you got what I'm saying, guys? So I don't need to do polling. I don't need to check if I received the data or not. Okay, all what's going to happen is once the microcontroller receives data using serial communication, all what you have to do just inside the subroutine, just to go to the subroutine, write a code in the subroutine just to take this data. Okay. So the idea is, as I told you in the very beginning of this course, guys, I told you microcontroller, when I explain the difference between microprocessor and microcontroller, I told you microcontroller is a complete system. That's true. So inside the microcontroller, there is a circuit for serial communication. So same thing I'm going to say in chapter number 5. There is another circuit for timer. That's why we call it timer system. Okay. So there is some hardware related to the timer. Also, there is hardware related to the serial communication and other things here. For sure, we are not going to teach everything in this course, but now I'm focusing on the serial communication. So there is some hardware circuit, okay, for the serial communication. So now you should understand number one. What do you mean by serial? Okay, serial data. When you transmit the data serial, what this means? Just one pin. Using this pin, I'm going to send the data bit by bit. Okay. And number two, you should understand what you should understand why we need interrupts here. Okay. And again, the good thing is the way I'm going to we are going to program the interrupt here is very similar to the way we did it before. Same thing is it's the same. You still need like this number as we did before. Everything almost still you have the enable bit. So everything is almost similar to what we did before. Okay. Number two, our next point here. So let me go through it. So here, guys, as you see here, number two, why you need serial communication? I'm going to tell you why you need serial communication. We need serial communication, guys, because, for example, this microcontroller want to communicate with another microcontroller. They want to communicate together, okay? In our case here, this board is going to communicate with another board. In this case, you can connect a wire from here, as you see it. I can connect a wire from here to the other board so that they can communicate together. There is another way. The other way is you can connect here what we call Zigbee. Okay. So we have a chip. You can put the chip here, and there is a jumper here. Okay. You can control if you want to connect the serial. So it's like we have here. We have SCI1. SCI1 can be connected to the wire, as I told you, so that you can transmit the data through a wire, or you can connect it to the Zigbee so that you can transmit the data wireless. Okay, so it's again programming wise, it's going to be exactly the same thing. If it is wire or if it is wireless, it doesn't matter. You got what I'm saying? Programming wise, because in both cases you are just using SCI. Okay, so if SCI is connected using wire or connected using wireless, it doesn't matter. You understand what I'm saying? You are programming SCI. So SCI is after that is connected to a chip, Zigbee chip, to connect it using wireless or using wire, it doesn't matter. Okay. So again, so serial communication can be used if you want to connect microcontroller to another using wire or using wireless, it doesn't matter. Okay, because still I'm not gonna program the wireless part. I'm just programming SCI. So if it is connected to a wire wireless, it doesn't matter to me. Okay. Also, so now again, serial communication can be used if you want to connect a microcontroller to another microcontroller, or you can connect a device. But this device should have a serial communication, right? You can connect a device to the microcontroller. This device can be a sensor or it can be a circuit, whatever it is. Okay, so you can connect it using serial communication. So here, what I'm explaining, we can use it to exchange data between microcontroller and another microcontroller, or it can be microcontroller to a device. So here, the protocol we are going to use, we call it TIA 232. This is the protocol we are going to use in communication. The way this is done using asynchronous. In communication, okay, if you want to do serial communications, there are two ways. Okay, there is one way we call it synchronous. In synchronous, you have to connect a wire here, Okay, in addition to the data, you have to connect another wire for the clock. So there should be a common clock. So clock means this clock is used for synchronization. That means here I'm gonna send one bit, so we are synchronized. I'm gonna send 1 bit, you are gonna receive it. Okay. Anyway, so this is a communication part, but here what we have here it's asynchronous anyway. Okay, so there is no clock. They use a different way. Okay. So anyway, so here I'm just telling you we have 2 types. When you want to transmit for data transfer, we have 2 types. We have serial and we have parallel. So how they are different? I'm going to tell you how they are different. Okay. So simply the idea is that, for example, if I want to send like something like 10 10 10 10, whatever, okay, something like that. If I want to send it serial, so I just want to put here 1 bit, and you can see here over the time. Okay, 10 10, only 1 bit. Okay, so this is one idea. The other idea is if you want to do it parallel. So the idea is that here I need 8 wires here, so that the 8 bits I'm gonna transmit the 8 bits at once. You got what I'm saying? Just I'm gonna send at once. For sure, parallel here is actually it's faster. For sure, it's faster. Because every time a clock, I'm going to send 8 instead of 1, right? However, for many small devices, I don't need this speed. I don't need too much speed to do it, right? Serial communication should be enough, right? Remember, when you connect your the port to your laptop, use the serial communication. It was okay. You got what I'm saying? So what I'm saying here. Parallel transfer can be used in case you need very high data transmission rate. Also, one of the difficulties here in the parallel, you cannot connect many devices. But think about it: if you have only 1 wire, so it's easy to connect many devices. Anyway, so I'm not gonna talk. So this is that's what I told you. This is the wire or the jumper. You have to connect it here. Okay. I'm not gonna, for sure, this is like a communication part. I'm not gonna talk too much about it. So you can see here, we have here, by the way, our SCI here, guys, is full duplex. Okay. So what do you mean by full duplex? I think if you have some knowledge in communication, that means we can transmit and receive at the same time. Okay. So this is the meaning of full duplex. You don't, for example, and if it is half duplex, that means at a certain time I should either transmit or receive. Okay. However, our SCI here is full duplex. That means I can transmit and receive at the same time. That means if you look at SCI circuit, inside the circuit here we have 2 parts. We have 2 parts. Okay. So 1 part for receiving, 1 part for transmission. That's why we can transmit and receive at the same time, because the circuit has two parts, 1 for transmit, 1 for receive. Okay. Anyway, so you can see here, guys, received data. So received data should come to this pin here. We have here transmitted data. So you are going to use only this pin to transmit data. This is the ground. You can see we have here other things related to the communication, like request to send, clear to send. Okay. This is, again, I'm not going to teach too much about it because it's more related to communication. If I wanna send the data, so I have to send a request first. Once request means I want to take a permission from you. I'm asking you. So it should be done here, okay? So before I send. So anyway, the data should be here. We agree on that. If you want to transmit, it has to be here. If you want to receive, it has to be here, okay? You can transmit and receive at the same time, but there should be some communication protocol to do that. In this communication protocol, for example, if I want to, you need to do something like request to send, clear to send, okay? Before I send, I have to take a permission from you. Anyway, So now I want now the data you are gonna send, the data format. The data format should have this format, guys. We have a bit in the beginning. This bit we call it a start bit. So any data you have to send, you have to put it in a frame. Okay. Also, this is something related to communication. You have to put it in a frame. The frame here, it looks like something like that. Okay. The frame is you have a start bit. Okay. This start bit here is always 0. It's always 0. And then here, this is the data. This data, it can be 8 or it can be 9 bits. You can control it. This is something you can do like configuration. You can configure the serial communication. You wanna, your information is 8-bit or 9 bits. This is something you can control. Also, you have here the stop bit. Okay. So again, just start and stop bit in order to tell the other side where is the beginning and where is the end, right? Frame, okay, to define the frame. Anyway, so the way you can use it, guys, if you have, and for example, if you want to send ASCII character, for example, so you can just use 8 bits. You can just put the data here. So usually, so here for stop bits, usually it is 1 or 2 bits. Okay. Anyway, so again, your data is like a byte. I'm gonna put this byte in a frame. Okay. Anyway, so now how can you program similar to what we did before, guys? Like what you did in RTI, I have to do configuration, right? So same thing here. Also, I have to write some instruction here to configure the SCI before I use it, right? So the first thing you can program is the baud rate, as I told you, baud rate. The baud rate can tell the speed. How much is the speed? How many bits you can transmit per second? So here for this board, these are the speeds we have here. This is the speed. So you can transmit starting from 300 bits per second up to more than 400,000 bits per second. This is the speed you can select. I think most of the people use this one. Maybe this is because it's somehow standard or whatever. So this is if you want to use this baud rate. So you should understand what I mean by baud rate. Baud rate again means the speed of the transmission, speed. Okay. So that means if I selected this baud rate, and for sure the transmitter and the receiver should have the same speed. Otherwise we are going to lose communication. You understand what I'm saying? We are not going to be synchronized. Okay. For synchronization, the two devices should have the same speed. Okay. So if you send and if you use 9,600 on one device, the other device should be used the same speed. Otherwise, we cannot communicate, right? Anyway, so now the question is, how can I program for any of these speeds? How can I program it? Very simple. So the idea is, number one, based on the clock you have. In our case, we use 24 megahertz. This is the clock. So the idea is, internally inside the SCI, we have 24 megahertz. This is the clock we use from the beginning of this course. This is the clock. What they do is, we are going to divide this clock by a certain value in order to generate the clock that's going to be used for the serial communication, which is this one here, or this one, whatever it is. Okay. So again, I'm going to take the main clock. I'm going to divide it by some value. And after I divide it, I'm going to get a clock for transmission. Okay. So here, for example, here in the table, I use two values, one for 16 and one for 24. We're going to use the 24 because we already in this course, we use 24. This is a system clock. Okay. Anyway, so all what you have to do, guys, we have a formula here. We have this formula, as I told you. We have here, this is the clock, which is 24 megahertz. This clock, we divide it. So we have here 24 megahertz. This is the main clock. First, we divide it by 16, as you see here, right? And then you are going to divide it by a value we call SPR. So this one, I'm going to divide it by SPR. And this should give me the baud rate, okay? So now the question is, what is the value of SPR to get a certain bit rate? And then this number you have to put it in this register. That's it. Again, best, let me say it in a different way. But number one, you have to select what bit rate you want here, and then you have to come up with this number. Okay, I'm gonna tell we use this number here using this equation. We came up with this number. All what you have to do to program a certain bit rate, all what you have to do, you have to take this number, you have to put it here in this register. That's it. Okay. And how it works, very simple. The way it works, it's 24 megahertz. I'm gonna divide it by 16, and then I'm gonna divide it more by this number, divided by more by this number. And the result is gonna be the clock I'm gonna use in the communication. Okay. And this clock should control the speed. Okay. So anyway, so if you plug it in, for example, let me give you one example. So for example, if I want to select this bit rate, so if just plug in here, put here 9600, you will find this value. I already give you all the possible value here, 156. I'm explaining how I came up with these numbers. Okay, how I came up with this number. Just I I take this bit rate, I put it here, and then why you need this number, because this is the number I'm going to use in the configuration. Okay, guys. So now make it very simple. For example, guys, I'm going to work on this speed. Okay, that means when I have to write 156 here in this register. That's it. Very simple. So just a number, put it in this register. Okay. In here, actually, it is here we have 13 bits. We have 13 bits. 1, 2, 3, 4, 5, and 8. So we have 13 bits. We have 13-bit number. These 13-bit number are in two registers, right? So now this number here are actually 13 bits. Okay. If you look at the biggest one, we need 13 bits. Okay. These 13 bits are in two registers, as you see here, guys. This is bit number 0, bit number 1, number 2, until 7. So this 8 in one register. This register is called SCI. As you see here, guys, we have here SCI 1 BDL. This is the name of the register. We have 1 and we have 0. Yes, because this is for SCI 0. This is for SCI 1. You will see right now every register, we're going to have two of them. One for SCI 0, one for SCI 1. Okay, guys. So again, so here the first, all what you have to do, guys, the number you have here should be 13 bits. 13 bits. These 13 bits, 8 bits are going to be in one register. The other one is going to be in a second register, as you see here. So here, this is the first 8 bits, and then we have here 5 bits, and then you can put 0, 0, 0. Is that okay? So number one, if you wanna program the bit rate, all what you have to do, you have to come up with a number using this table and this equation, and then this number you have to write it in two registers here. Okay. What is the name of these registers? Yeah, this is a 1. This is the second one. Okay, guys. Any questions? Okay, this number 1. Number 2. Also, similar to what we did before, we have a number of registers. You can program the SCI by writing some numbers to this register. So let's see this one here. I told you guys you can send 8 bits or 9 bits. I told you that. Okay, so here your data, it can be 8 or it can be 9, whatever you like. Okay, so how I can do this? How I can tell as a SCI, I want it 8 or 9. Very simple. So you have here 1 bit. As you see here, they have only 1 bit in this register. As I told you, every register we have 2 of them, 1 for 0, 1 for 1. Okay, so just we have 1 bit here. So if you put 0 in this bit, so you are telling SCI, I want to transmit 8-bit data. If you put 1, you are telling SCI, I'm going to transmit 9-bit data. Okay, guys, any questions? Very easy. Okay. The other thing here, we have another register here. This register, we need these 3 bits. The first bit here is the interrupt enable bit. Okay, enable bit, similar to the enable bit I explained for IRQ and RTI. Similar to the enable bit I'm going to teach in chapter 5 as well. So just one bit to enable or disable the interrupts of reception when you receive, okay, of the receiver. That's it. So this is the enable bit, which is this bit here. In which register? In this register, SCI1, CR2. Again, we have two of them, one for SCI0, SCI1, okay? Now, we have another two bits here, guys. One bit in order, again, I told you, if you look at SCI, guys, we have, every SCI, we have two circuits, two separate circuits. One for transmission, one for reception. Is that okay? Anyway, so here we have two bits. These two bits, one for transmitter, the other one for receiver, to enable or disable. So these two are not about interrupts. Okay, this one, do you want to enable? For sure, I have to enable them if you wanna receive and transmit. Okay, so if you want to enable the transmission, you have to put here 1. If you want to enable the reception, you put here 1, or you put 0 if you want to disable them. Okay, and this one is for the interrupts. Okay. Also for this register, guys, SCI, I'm going to accept some register and then I'm going to put everything in one program. You will see it's not difficult at all. It's easy. So for example, here in this one, guys, we have these 3 bits here. These bits, it's the last bit here. Is this one should tell you if the transmit data register empty flag. Okay. What this means? I'm going to tell you what this means. Look here, very important, because this is what I'm going to use right now. Look here, guys. This is SCI 1 or 0, doesn't matter. Okay, so here we have transmit. We have 2 parts, transmit. Here we have a buffer here, a buffer, right? So all what you have to do in your program, you are gonna write you have a register, buffer, right, or a register. All what you have to do if you want to transmit data, you have to write the data here. Okay, so for example, I want to send 3A. All what you have to do just to put 3A here in this register. Is that okay? However, because microcontroller is much faster than SCI, I can't just take this value, take this value, take this value. I cannot do that, right? Before I write to the buffer, I have to make sure the buffer is empty. Empty here means, because the idea is that once I put here a number, for example, the 10, 10, 10, and so on, so this one is gonna shift. It's gonna do like shift. It's gonna transmit bit by bit, 0, 1, 0, 1. So it's gonna take some time, right? That is why, as you will see right now, guys, before I write to the buffer to transmit any data, I have to make sure the buffer is empty. Empty means it's already finished transmission. How? All what you have to just check this bit. Okay, as you will see right now this is the program. For sure, I'm going to explain you the details. But as you see here, guys, here, I'm going to check this bit here. I'm going to check this bit. As long as this bit is 0, I'm going to keep looping here. I have to wait. As long as it is 0, I have to keep looping. I have to wait, right? That means the SCI did not finish the transmission of the old value. So I cannot write a new value. So I have to wait. So this is just one bit to tell me if the buffer, if it is already finished transmission and the buffer now is ready, I can give a new value or not, right? So now here I'm gonna wait, I'm gonna keep looping because I need to check this bit. Once this bit is 1, that means it's already ready. Okay, so what I'm gonna do now, I'm gonna call, so once you come here, I'm gonna call a keypad. I'm gonna get a value from the keypad, and then I'm gonna write it. I'm gonna write this value in this register. This is the buffer I told you about. It's very simple. Okay, guys, this is how can you transmit. So transmission is easy. Again, in order to transmit, you have to do 2 things. Okay, for sure. In addition to the initialization, I'm gonna talk about the initialization. But after you finish the initialization, if you want to transmit, you have to do 2 things. Number 1, you have to make sure the buffer is empty. And what do you mean by the buffer is empty? That means when I give some value, it's already transmitted, and now it's ready to give another value, right? How can you do that? Very simple. I'm going to check this bit. Once this bit is 1, that means now it's empty. Now the transmission is ready to receive another value, right? This is number 1. Number 2. Okay, so how I can write some value? Very easy. All what you have to do, you have a register, so you can write this value to this register. This is a buffer. So just whatever, once you write, so it's gonna start the transmission. You got what I'm saying? So two things here. You have to make sure the transmission is ready, or the old value is already transmitted, and now the transmission is ready to receive another value. Okay, how can you transmit another? As you see here, guys, I'm gonna take a value from the keypad, okay, and then I'm gonna send this value to put it in this buffer. Again, once you put it in this buffer, that's it. Everything else is gonna be done by the circuit. Remember, SCI is a circuit, right? It's a circuit here. All what you have to do, you have to initialize it, and then you have to just write some value here and just leave it. Once you do that, it's gonna start the transmission bit by bit. Okay. Anyway, also we have 2 bits here, guys. Another 2 bits here for the receiver. So we have one here. This one transmission is completed. So this one it is gonna tell you if transmission is completed. This one for flag bit, receiver flag bit. You remember we have to clear this bit in the receiver flag bit. Okay. Okay. Anyway, so next time I'm gonna show you. I think it's already finished. So next time I'm gonna explain this program. Gonna show how can we transmit data or receive data, and so on. Okay? And then I'm gonna start chapter 5 next time. Okay. As I told you guys, on Thursday, this Thursday, this is the last Thursday in this semester. So we're not gonna have a lab, okay? Instead, we are gonna have, if you finished your project and you want to demo, you can demo. If you need help from the TAs, so we're gonna have a session on Thursday. The TAs are gonna come, and then if you need any help in your project, if you need to demo your project, we have all of that. Also, we are gonna distribute a sign-up sheet. You have, as I mentioned in my email, you have another 2 days, okay, if you want a demo. So one day is gonna be, I think it's gonna be, as I mentioned, in December 8 and December 9, okay? So we're gonna distribute a sign-up sheet to reserve a time slot for your demo. Yes.
If we were to demo Thursday, we have to have the report to turn in with it on Thursday.
So I'm totally fine. If you want to just finish the demo and you can email us the report later, I'm totally fine. Okay. One more thing, guys, I want to tell everybody, if you did a good project and you want to put it on the YouTube channel, please record the video. Anyway, it's a good idea to record the video anyway, because it happens in the past. Maybe you have a very good project and then it works very well, and then for some you dropped it, or it happened before, or a device like broken, or you burn it out, whatever. So now it's not working anymore. It's a good idea if your project is working, just take a video. At least when you show us the video, we're gonna grade it based on the video. I'm totally fine. You got what I'm saying? And also you can email this video to put it in YouTube. Okay. Thanks.